Hello, everyone. A very good evening to all of you. I hope you had an amazing day. And I hope yesterday's session was very engaging and very, very informative to all of you. We'll just wait for a couple of minutes more for everybody to join in, and we'll be just starting. Meanwhile, you guys can, chat with us in the comment box. Hello, hello, hi. Hello, everybody. Hi, how was your day today? Let's flood the chat box. I hope I can see everybody who was in the yesterday's session as well. Hello, Sagar. I can see 30 people on live right now. Let's wait for 2 more minutes. We'll be exactly starting at 8:05. Till then, let's just... Hello, Rakshita. Rakshita was there in the first session as well. Paritosh, hi. Devansh, hello. Come on, everybody. Let's flood the chat box. Hi, Piyush. Hello, hello, Charan. Hello, Siddhant. Boring college day. Devansh is boring college day. Okay, so let's talk on how was your day today. Was it boring? Was it exciting? Was it amazing? Yeah, hi. So, Charan, today's agenda is that we will be giving you a hint about robotics, introduction to robotics, and also some of the very useful softwares that are used in the robotics industry. Hello, Kuldeep. Hello, Jitesh. Hello, Sagar again. I can't pronounce this name. Hello. Hi, everybody. Had a fun day. Okay, so we did this yesterday as well. So let's follow the same drill. Kindly give me your year. In which year are you right now? And what is your branch of study? Hello, Piyush. Hello, Sujal. Hello, Ajit. Hi, everybody. Okay, so I just want to know the audience that we're catering to today. So just let me know that which year are you guys right now and which branch are you from? Hello, good evening, good evening. Hi. Hello, Ajit. Hello, Surujan. Okay, so we have Jitesh, first year CSC, Devansh, third year, Rakshita, final year CSC, Paritosh, first year aerospace. Ruchita is CSC, cybersecurity, third year. Sujal is first year CSC. Okay, so this is a very important information for our mentors of the day as well. Because, if you know your audience, you can give them what they want, right? Okay. So Charan says, I'm a final year bachelor student pursuing mechanical specialization in mechatronics. That's great. That's great. Arjun is in second year CSC. Adarsh, second year CSC. Cybersecurity. Wow, great. So we have a diverse audience today. I would just like to tell my mentors that. Okay. So we will just start with the session. We have two of our amazing mentors today, right? So yeah, so I would just want to give a brief introduction on what was done yesterday. So yesterday was a artificial intelligence and machine learning class, and the code that was given by the mentor in the session will be shared with all of you by the end of the third day, right? So you can practice that code. And the recording of the first day is also present on our YouTube channel. So don't forget to view that. Now, coming to today's session, we have two of our mentors. First is Mr. Orko Banerjee. Second is Ayushman Jena. Orko will be taking up the first half of the session. And Orko is our very own technical head at My Equation as well. And he has taken 30 plus workshops with us, with My Equation. And today he will be telling you about the heart of robotics, the mechanical and mathematics of robotics. And Orko has worked with the various industries, including Amnex, Weimar Motors, and currently he's working at Dematic. So Orko, over to you.
Sure, Tanya. Thank you. Thank you for your introduction. And hello, everyone out there, right? So first of all, again, as Tanya mentioned, I'm Orko, and I'm currently working with Kion Dematic as a mechanical design application engineer. And so my field of work will be robotics that I'm currently serving, robotics and smart automation. And apart from that, I'm also pursuing my master's from BITS Pilani in automotive engineering. So that's about about me. And in today's session, what we'll be learning is that I'm pretty sure most of the people who are in this meet were in the previous batch where Basleil gave the codes, right? However, in mechanical or mechanics, we don't deal with codes, right? We deal with numbers and data. And again, the entire course of mathematics and robotics is vast, right? I mean, engineers and scientists spend their entire life just investing, or let's just studying about one factor or a part of robotics, right? That's all that they do. However, in today's session, we'll be learning about one of the most important concept of any moving body that we have, degrees of freedom. Okay, and once we have a list of degrees of freedom, we can surely move ahead to, let's say, translation matrices, DH matrices, which will be again covered in the workshop that we'll be hosting for all of you, which again Tanya and Teeth will be giving you a brief. In a while. Okay. So I'll be casting my screen here on. So again, as will be two of us. It will be me, Orko, who will be giving you a small introduction or a touch-up of degrees of freedom. And since the World Cup season is going on, I'll be giving you three important, or let's say three fun examples that you can relate degrees of freedom with, right? And once I'm done, Ayushman will be taking over, and where he will be giving a brief introduction of, let's say, SolidWorks, etc. Okay? So I'm sharing my screen here on. Give me a second. Yeah. Is it visible, Tanya?
Yes, it's perfect.
Okay, sure. So we'll be learning about a small introduction of robotics today. Before I start, can we all name these robots, right? I mean, I'm sure pretty much everyone has seen these robots in articles, webinars, or whatever, right? Can we all name these robots? I'll just give you everyone 2 minutes. You can drop down your answers on the chat box. And Tanya, just give me a verbal thumbs up whenever they're done in 2 minutes.
Come on, everybody. I believe most of you would have seen some of these somewhere or the other. So let's have those answers. And even if you don't know, and you can just put up some funny random robot names that and the mentor will tell you if they are correct or not. Okay, so Orko, Aryan says Sophia. Okay, guys, so you can just also, put a number before, so which robot is Sophia? So Soumya says, yeah.
Aryan, one of your answers, Sophia, is correct, but you need to tell me which one is Sophia. Okay?
Yes. So Soumya says third is Atlas.
Yes, Soumya. Bravo. You're bang on target.
Pragyan Singh says fourth is Sophia.
Fourth is Sophia. Bravo again.
Yes.
Bang on.
Rakshita again says fourth is humanoid robot Sophia. Paritosh, Sophia. Everybody knows Sophia, I believe. Okay. So Abdu here says third Atlas, right? Boston Dynamics. Okay. Great. Okay, yes. So most of the answers are Sophia, Atlas. Nafis says first is a mecha. I hope I'm
Yes,
pronouncing it right.
Nafia, correct. The
Uh,
answer for the first one is Omega.
yes. Then Kuldeep says second is Armar 6.
Arman 6,
ARMAR.
perfect.
Armar 6.
Bang on.
Okay. Nafis also knows America. Devansh says Richie Ritz maid. We all know that was a robot, yes. Anshul Raj, fourth Sophia, third Atlas, Sophia, first Emeka, second Sophia, second, fourth Sophia.
Mhm.
Most of the answers are Atlas, Sophia. People know
Yes,
Atlas and Sophia most.
perfect. So I'm pretty sure I'm catering to a very uh, well equipped and let's say well developed and a well to known audience out here. So the first one is Omega, as many of you spotted out. Two is Armar 6, yes. Third is Atlas, designed by Boston Robotics. Fourth is Sophia. Fifth is Pepper. Uh, and the sixth one is Robonaut 2. Again, it was designed. It was used by NASA later on for their Mars rover operations, and also to mimic a human action. So they wanted to send an astronaut without having an astronaut as a human being. That's what their main motive was. Now, as you can see, all of these robots, or except let's say third robot, which is the service robots, all the robots are service. I mean, are humanoid robots, right? Which depict or which mimic the action of human beings. Okay, so that's what again our main motive is to mimic human actions. So all of these robots, except third, which is a service robot, are humanoid robots. Okay. Now, what is robotics, right? Now let's not go into the bookish definitions, etc. Let's not go into the data. Let's not go into mathematics. So the word robota or robotics comes from a Czechoslovakian word called robota, or the word translate into the word called to serve humans. Robota to means to serve humans in Czechoslovakian. And again, most of the developments and studies of robots, initial robotics was done in Czechoslovakia. So most of the engineers you'll be finding will be from Czechoslovakia again. So a very over the top definition of robotics is something which can something which can mimic a human action with its own intelligence. Now there's a difference between a machine and a robot, right? All the mechanical engineers out here, right? I'm pretty sure we must be designing machines. We might design pumps, we might design motors, etc., etc., etc. Right? But when we are combining, or let's say when we are bringing out all the subdomains of mechanicals, electrical, electronics into a multidisciplinary, that's what is called as robotics. Okay, and the field of robotics, or I'll say like the school of robotics that serves robots is mechatronics. Again, something that I did in my bachelor's. Okay. So uh, again, if I have to redefine the entire definition, it is a subdisciplinary domain or a baby of many different domains, which will aid or which will enable human action to be replicated, or not only human action, any action to be replicated. And the other difference is a robot will be having its own intelligence, unlike a machine. A machine can do a repeated job, however, a robot can decide for itself. Now let's dive into the a very important concept of mechanics. That I mean, this entire concept will lead you, or let's say, will push you towards the other important topics of robotics. Let's say the DH matrices, the translational, the homogeneous matrices, the rotational matrices. But before that, we need to know how a body moves in space, right? Any body moves in space. Now, for example, if I have to move from point A to point B, there are two kinds of motion that I can depict, or let's say have, right? The first motion that I can have is of a linear motion, right? A straight path. Now, again, we all have learned, or let's say we have all have seen in the um, what to call seen in environment, right? There, I mean, or in basic mathematics that we all know, there are three axes: x, y, and z. Now, in x, y, and z, or the 3D plane, you can have two motions. One is a linear motion, and the other is a rotational motion. Now, what does this gives us as an output, right? The output is that you can move in all the three axes in either rotational, linear, or both. Now, coming to the linear motions, right? Now, you can either move in x direction or y direction or the z direction, right? So that will give you a translational motion or a linear motion in three axes: x-axis, y-axis, and z-axis. Yes. So those are the 3 degrees of freedom in a linear path. And the other 3 degrees of motion are the rotational motions, right? Which we'll be learning with examples of the bowlers that I'll bring out soon. So a body can move in x direction, a body can move in y direction, and a body can move in z direction again. Now, in this case, in a rotational motion or a rotational manner. Yes. So now in this condition, again, as the similar to the translational one where it shows x, y, and z axis motion, now it will be having x, y, and z axis of motion in a rotational manner. Now, whenever, yeah, I'll come to the definitions of roll, pitch, and yaw. Okay. Now, as you can see, whenever the body is rotating around the x direction or the x axis, we're calling that as the pitch. Okay. Whenever the body is moving around the y-axis, the body is rotating around the y-axis, it is called as the roll. And whenever the body is rotating around the z-axis or the vertical axis, this will be called as the yaw. Okay. Now again, it's the World Cup season that's going on. We'll come to those. Before that, let's see. Right now, this is a train that's moving in a linear path. Okay. Now, can we have how many degrees of freedom will this body have, and in which axis? Everyone in the chat. Tanya, just give me a verbal cue when the people have, let's say, given their answer.
Sure. We're waiting for your answers, guys. They're saying one.
Correct.
One x-axis.
One on x-axis. Perfect.
Devanshu says two.
It's an ideal case. So we are just seeing the body is moving in the linear path in x-axis. So in this condition, it will be only having a degree of freedom of 1, moving in a linear path. That's all. So whoever answered one as the answers, they're bang on target. Good. Second is, this is a seismograph. Now, ideally in this picture, it might not be very visible, but I'll just give out the mechanism. This entire mechanism has two joints or two roller joints, which is rotating in two different axes. I gave you the answer. So now, how many degrees of freedom this will be having? Everyone in the chat, and Tanya, you can give me a verbal cue.
Yes, so we have a second question. Piyush says one-dimensional.
For the second question?
Yes.
Hear me out, everyone. In this condition, in this mechanism, we have two joints. A roller joint which is rotating, and both the joints are rotating in two different axes.
Yeah, we've gotten a lot of answers now. Everybody says two.
Yes.
X and Y axis.
Correct. So the entire thing is moving in x and y direction. I mean, rotating in x and y direction. Now, what was x-axis? Now, x-axis was the pitch movement, right? And the y-axis was the roll direction. So we are getting the gist of it. So it's good to know. Now, this is a submarine. Can anyone tell me the number degrees of freedom this will be having? With the axis, of course. Tanya, give me a
third question. Yes. Okay, so answers are coming in. A lot of people are saying 3. Mayank, Kuldeep, Pragyan, Rakshita, Divansh, and a lot of them. Everybody is saying 3.
Okay. So the answer to this is 6. Why? Let me tell you. A submarine can move in X, Y, Z direction in a linear path. A submarine can also roll, or let's say rotate in X, Y, Z axes. So this will give you 6 degrees of freedom, as you can see, right? So 3 in the linear and 3 as rotational. So 3 plus 3 is 6. Now we're coming to the next topic. Let's discuss this first before coming to this equation. Let's discuss this first. Now, people can see my screen, of course, where we have Bumrah out there, and we have, now imagine my hand out here, right? And I'm holding a ball, for example. I don't have a ball with me right now, but anyways, now imagine this as a ball. Okay. Now Bumrah, when he bowls, right, he moves his wrist. Okay. Is my video visible, Tanya? Tanya, is my video visible?
Yes, your video is visible, Orko.
Okay. So when Bumrah is bowling, I'm trying to depict his wrist movement in my video, where my face is visible. So this, for example, this is the x-axis. So my wrist is rotating around the x-axis. So what kind of motion do we have here? A rotational motion around which axis? X-axis. And what is this called? In the chat, please, everyone.
Rakshita says rotational motion.
And around the x-axis, she is correct. And what is the name of the motion then?
More answers, guys, please.
Do we have the answer, Tanya?
People are saying rotational motion.
Correct.
2 people
So
have
this is rotating around the x-axis, which is the pitch.
Yes. Pitch
Now let's
started coming in now.
Correct. Now let's see Malinga, or let's say Malinga is retired now. Let's think about Pathirana, who is having an action similar to him. Now Malinga or Pathirana, both of their actions is like this, right? Their arm movement is like this. So in this condition, around which axis is my arm rotating? Around the vertical axis, that is the z-axis here, right? So now what was the motion, rotational motion around z-axis called as? In the chat, guys, please. Do we have the answer?
Please, everybody. They'll just come in a moment.
Sure. So this is a rotational motion around the z-axis. That was what kind of motion, guys?
People are saying YAW.
Correct. Yaw. Perfect.
Yaw.
Now let's see.
Rotation plus vibration.
Perfect. Now let's see Ashwin. Okay. Now imagine my wrist as Ashwin's wrist, right? So now how does Ashwin balls? He balls something like this, right? Yeah. So if you see it clearly, this entire motion or movement will be around the which axis, guys, in the chat? So where we saw x-axis with Bumrah, we saw z-axis with Pathirana or Malinga. Now in Ashwin, where the wrist moves outward, right, with this axis, my wrist is rotating, right? So this will be the y-axis. Now the y-axis is what kind of motion?
Okay, so we have a very nice answer. Charan says x-axis pitch, y-axis roll, z-axis yaw.
Perfect, Charan.
And Kuldeep and Rakshita have also said roll.
Perfect. There you go. Okay. So we now have an understanding of the rotational degrees of motion. Okay. So it's going good. Now let's see. Let's come to a little mathematics. We won't dive deep into it. A very over-the-top mathematics. Okay. How to find the degree of freedom from a robot, right? I mean, if you just see a robot, how will you find the degrees of freedom? How will you understand what kind of motion it is, right? So the formula was given by the engineer Kutzbach, again from Czechoslovakia. So the formula states as 3L minus 1 minus 2J minus H. Okay. Now what does this mean? Now L is the number of links. Now in robots, right, I'll be giving a small description of what link is, right? Now imagine my hand out here, right? Imagine my hand out here. My bones will be my link, which will be giving me the support. Okay. And J is something called as joint, right? Now joint is something which will be holding the two bones out here. So now we have two links and one joint. Okay. And now what is higher pair? Now imagine, let's forget about higher pair for now. Okay. Now imagine only my hand out here, right? So I have two links out here and one joint. What will be the degree of freedom without the higher pair? Forget about the higher pair for now.
Answers, everybody, please.
Yes. Do we have the answers?
There haven't been any till now.
So okay, let's go through this entire thing one by one. Now 3, L is the number of links. So in this condition, I have two links, right? So 3, 2 minus 1. So that's 3, right? 3 into 1 is 3.
Okay, Orko, we have some answers coming in.
Yeah, go ahead.
Pragyan Charan says 1, Mayank says 6, Mohit says 2. And a lot of them are saying 2, and some of them are saying 1.
Yes, correct. So ideally, the answer should be 6. Ideally, I mean, if not ideally, biologically, because you can depict all kinds of motion out here, right? But Kutzbach equation is not for biology, right? It's for some engineering concepts. So out here, I have at this instance, which I'm only showing this kind of motion out here, right? Only this kind of motion. So now what would be the degree of freedom out here will be? There's only one kind of motion, right? So 3 L minus 1, that's 3, and J is 1. So the answer will be 1. So you can see there's only one kind of rotational motion that's being showing out here. Okay. So the answer is 1 out here. Now, again, in robotics, we have point-to-point contacts. I mean, we have different kinds of contacts, right? So the kind of contact is known as higher pair or lower pair. Whenever the two links or bodies are having a surface-to-surface contact, when both the surface are in touch with the other surface, it's in higher pair. And whenever the body is having a point or a tangential contact, it's a lower pair. Okay, that's what it is. So now, for example, if I'm if I'm rubbing my palms with each other, it's in higher pair because they are surface-to-surface contact. Okay. Whenever, for example, whenever I'm writing with a ballpoint pen on a sheet, yeah, it's a lower pair because it's only a point contact. So that's what it is. That's what I'm trying to say. In robotics, again, I'll be showing you much more examples when we will be having the main workshop out there. But for now, whenever a body or let's say links will be having a surface-to-surface contact with each other, it will be a higher pair, else a lower pair. Now, for a few more examples, whenever a nut and a bolt, it's a higher pair because the surface of the nut and the bolt are in contact with each other at all times. Okay? When we have two gears, right, an idle two gears, there will be only one condition or one point when it will be meshed. So that will be a lower pair. Yeah. So that's what it is, a higher pair and a lower pair. So this is the ideal or the most basic formula when we have to find out the degree of freedom for Kutzbach. Okay. So yeah. So the last slide from my end. So I'm pretty sure people must be knowing where robots are used for these days, right? It is used pretty much everywhere. Okay. And I'm working for a company which is into smart automation, right? And mostly our clients are Nike, Amazon, their warehousing, etc. So all their warehousing operations, for example, picking up, dropping, stacking, uh, whatever you can think of, is done by robotic arms. So we have one application there for warehousing operations, yeah, for manufacturing operation, for construction, for in medicine, whatnot. The list goes on, right? So, but however, majorly it's used for manufacturing because you can manufacture n number of products within a given time. However, if you could have, if you have done that with manual thing, that would have taken lot much amount of yeah, money, resources, space, etc. Right? Robot is a savior, right? We all know the why robots are used, why robots are replacing human beings. I won't be getting into those nitty-gritties of it. But however, this is what I had planned for today. I hope it was informative within the span of half an hour. Whatever I could teach you, I at least taught you the basics of movement that we all know in robotics. And yes, I can take some doubts. Else, we can go ahead with Ayushman, Tanya.
Yeah, I'll just wait for like 30
Sure.
to 60 seconds till the doubts come in. Otherwise, we'll just move ahead. Put your doubts in the chat box, guys. If you have any related to the topic or related to the field, if you want to ask Orko sir anything that you would want to know, then you can just ask away right now.
And else, you can also approach me on LinkedIn. I think Tanya can share
Yes.
my LinkedIn
Yeah.
ID over chat.
Sure, sure. I'll just put it.
I'll be available there as well.
Yeah. So you can just reach out to Orko on LinkedIn as well. He will be just sharing his ID. Okay, guys, can we please have the doubts in the chat, please? Arjun is asking, how much time does it take for one to know robotics?
Arjun, if I have to be very honest, it takes a lifetime. Not even a lifetime. It takes more than that, to be very honest. But
Okay.
yeah, everything goes in a process. It starts with bachelor's, if you want to start with. You can take your master's after that in robotics, specialization in electronics, electrical, algorithm building, mechanics, mechanical design. Yeah, there are different fields. And once you're done with that, you can take your PhD. And once you are done with these three levels, the race just starts. After that, you have to invest your entire life, your everything, into development and research, right? Ayushman is into R&D. He can also comment on the same. Ayushman, how much time do you think it takes for one to learn robotics?
It does take a lifetime here because like it's very multidisciplinary, right?
Exactly. So because you are having, it's a baby of many departments, right? If you only learn mechanical, you'll be good in mechanics, but you won't be good at robotics because
Electronics.
you're still left with electrical, electronics, systems. The list goes on. I cannot even count, right? If you ask me, do I know robotics? I know a segment of robotics. I might not be knowing robotics, but might be knowing a small percentage of a segment in robotics. So in my workshop, I'll be teaching you how to build algorithms through mechanics, how to understand space. Yeah. So that's what it's designed in the course for everyone. Yeah.
Okay, so Orca, how many doubts would you want to take right now?
We can take
Because
a
there
couple
are
of
many.
because yeah, we can take a couple of more. I mean, 2 to 3 more. As I think Ayushman is also in line. I don't want to steal his thunder.
Sure.
Yeah.
Okay, so I'll just, take a couple of
Mhm.
more doubts. So the second one is, Charan says, can 3D printing replace robots in construction or civil engineering?
Yes, they can. They can. But one thing, robotics cannot. I mean, it is still stealing from you the intelligence, because your skills can never be replaceable, right? The skills will always be there. A good engineer will be a good engineer, right? Even for a constant development, you need a constantly good engineer who's always learning and developing his skills. Yeah, and that's what we are here for, to help you develop your skills, right? And once you develop your own skill, you can develop a more skillful robot. And once that is built, you might think, okay, the competition is done. Now then you have to upskill yourself more than the robot that you have made for yourself, to upskill that robot again. So there will be always a chain that will be going on. So you have to be always in this loop of upskilling yourself. But yes, coming back to your question, sorry, I drifted from your question. 3D printing can, of course, I mean, it is 3D printing is anyways developing your PCB boards. Yeah, again, Ayushman is a person who has done it himself. He already has done 3D printed a robot, and even our founder Ratik, he has also 3D printed PCBs, right? So PCBs, once you develop a PCB, and once you develop the body of a robot, it's 80% of a robot is already built. So yes, you can. And even assembly part of it, it's also that can be also done by robots. Yeah. So a robot can build a robot, to answer your question.
Okay.
Yeah.
So the next question is Mohit is asking, sir, if we want to go into this field, what's the basic requirement from scratch to advanced?
Okay. So again, this answer will be a fusion of all the answers I gave as of now. Uh, it depends again in what kind of expertise you want to gain in this subject. Now, if you want robotics as your, let's say, career, you can always start with your bachelor's, gain some experience in a robotics oriented field, just like what I did. Okay. And then if you want support, if you want to develop your own career, you have to take a master's, because to be very honest, in this kind of cutthroat competition that we all are seeing now in engineering, and with the market saturation, without a master's degree, it is quite tough to survive, to be being very honest. Any kind of master's degree, but if you want to saturate yourself into technical, a MTech degree should suffice for you to have a good career in robotics. But again, if you want to go into research, PhD is your gate. Yeah, a gateway.
Okay. So just like, I guess I'll just take 2 to 3 questions more. Is that fine?
I'm fine if it's fine with Ayushman and you.
Okay. The next question is there any other microprocessor that you would recommend other than a Raspberry Pi, as it is extremely expensive right now, and any website to find it for cheap?
I might be wrong with this because I do not have my expertise in it, but I think Ayushman is at mega processor a good replacement for
Not exactly a good replacement. Like he's asking about processors, right?
Mhm.
So Raspberry Pi is the cheapest processor that you can get in the market. But like in substitute to that, why not use the controllers first? Like microcontrollers are the best thing that you can do as a hobby right now. Like, are you looking for a professional chip building, or are you just looking for board, a shield that can be easily connected with servos and all, and then you will be using it? So like just to tell it in crux, it's better to go for the microcontrollers if you are looking for now as a hobbyist, right?
Yeah.
Okay. So just the last question, Orko, then we'll move on to Ayushman's session.
I can't hear you.
Okay, so Devansh is connected. I'm audible now?
Yeah, better.
Okay. So Devansh is asking, can motions of machine can also be predicted? Like a machine can jump if a bump come, will it consider a part of freedom of motion?
I mean, motion planning you are suggesting, Tanya? I couldn't get the question.
That is the question he's asking. I guess he's asking,
If you could repeat
can
the
a,
question.
can a machine predict unpredictable motions? Like if
Yeah,
a
they can.
bump is coming, can a machine predict that?
Yeah, they can. So there are few. I mean, considering it as a completely mechanical thing, if not a robot, right? If you consider as a machine, because the question says machine, we have a concept in mechanical called as the predictive maintenance or predictive analysis. Yeah, one of my research papers is into that. So if you know the environment, you can consider, you can read the, or you can study the environment. You can find a data set of the environment, and you can feed the data set into the machine, so that machine can, with the neural network that is developed in the machine, you can feed the data into the machine with some iteration. It can predict, okay, fine, in this environment I might have this. So it can't say with complete conviction, but it can always predict. However, with robots, it can predict by a system called computer vision or machine vision. Okay, again, Ayushman is a better person who could answer this question with computer vision and machine vision, because again he has expertise into it. But yes, computer vision, machine vision is it's more or less like the eyes of the robot, right? So when you code the entire camera that is taking the data from an environment, it can say, okay, the entire data space that was completely blank till now, I have a small hindrance. Now, okay, that hindrance might be a constriction to my motion. So it can predict, or it can say, okay, there is a motion. So computer vision, machine vision, and predictive maintenance and analysis are the four concepts that can be deployed to understand or to predict the entire motion. I think I have answered your question. Sorry, I mean that a lot of people out here I can't be answering, but anyways, I'm always available on LinkedIn. You can text me, you can ask me your doubts, and you can also route your doubts to Tanya and she can send it to me. Apart from that, I'm looking forward to seeing all of you in the workshop that we'll be having. We'll have fun, we'll build algorithms, we'll understand space, we'll understand the axes, we'll be learning a lot in mechanics, right? So as of now, Shabba Khair, Rabraka, thank you.
Thank you so much, Orko, for your time. It was a great session, I'm sure. Okay, so everybody, I know there are a lot more doubts that we couldn't cater to right now because of the time constraints. We'll be moving on to Ayushman for the time being, and Orko will be here with us, right? So by the end of the session, we can again take up some doubts. You can just let me know whom your doubts are for. Is it for Orko or for Ayushman? And it will be directed accordingly, right? So Ayushman, over to you.
Thank you, Tanya. Thank you, Orko sir. So, hello to everyone. I am Ayushman Jena. So let's dive a bit deeper to the spicy side of robotics, right? So previously you just learned about the mathematics and complete calculation that before the designing process of a robotic structure, right? So let us just consider a part of it for now. So you learned about different parts of a particular robotic system, right? We have joints, we have actuators, then we have the links, right? So those are just fundamentally to understand how a particular robotic system might work if it is given some sort of force or some sort of energy as its input, right? So just to broaden out the topic on its own, we have some actuators, right? Most of the electrical and electronic people must know about actuators that are the force generating objects, right? So it will produce some sort of motion based on whatever energy it is being provided from a source, from a battery. And what it does is it transmits that particular energy into a system of mechanical structures that are connected through these joints, right? We have different links that are connected through these joints. So the best example that we can actually understand or that we can actually take currently is a robotic arm, right? Robotic arm is a very versatile thing that is being implemented in almost every robotic system that we can find. So if some of you could name the robotic arms that are available in International Space Station, have you heard of it, right? We have an ISS, International Space Station, that goes right up our atmosphere, right? Still orbiting around the Earth. So do you know what all robotics arms are being implemented over there? Have you heard of it?
Anybody? Any answers? Ayushman, if you could please repeat the question once again.
Yeah. So basically, the International Space Station that is orbiting the Earth currently, it has some robotic arms implemented into it for its maintenance purpose, right? So, could you name those arms, or at least the name its origin? Which country has developed till now? Like there are two really popular names in that.
I
So
guess this one might be popular. So Abdu says Canada.
Yeah, Canada is the right
C-A-N-A-D.
answer. Can someone name the other country? By that time, let me just present my screen.
Okay, so is the Canada thing called Canada?
Yeah.
Because
Canada
he has,
2,
yes, he's named that only. Anybody else? Anybody else knows anything? Divyanshu says Japan and Sagar says China.
Not exactly China. Russia is still trying to get there, but Japan is the right answer. One is the Canada, the other is the Japan. And recently, European Space Agency has also been trying to develop a robotic arm that can be manipulated. So like you learned about the different degrees of motion or degrees of freedom, to be specific, right? When you are considering an arm into it, like designing an arm. So we have a variety of joints, we have a variety of links that can be designed. And then we have something that is known as the end effector, right? So here we can see an example of the end effector. And this particular software is one of the very versatile softwares that you can come across in designing the structure of the whole robotic arm or the structure of any device that you are planning to do, right? So it is the SolidWorks. So like how many of you are acquainted with SolidWorks? Can I just get a number in general, like out of our audiences? Just raise a hand or just tell me something like that.
Guys, just put in a yes if you know about SolidWorks.
Is my screen visible properly? Like
Yes,
no
yes,
lags
it
and
is
all. Okay.
visible. Yeah. People are still stuck on the previous question only. They are still answering. Japan, Europe. Okay, come on, everybody. I guess SolidWorks, so a lot of you might be knowing. Okay, so Charan says he knows.
Very good.
Yeah. Kuldeep knows it. Anshul knows about it. Rakshita says yes. Hiten says no. Subbalakshmi, yes. Mohit, yes. Arjun, yes. Abdu is saying heard about it but never used it.
Okay, cool. So basically, some of you know, some of you don't, and some of you want to learn about it, right? So SolidWorks is actually a very robust software that can actually help us create physical 3D models of whatever structure that we have imagined earlier, right? So every design procedure, now before you start designing or before you start jumping into the complete design procedure, you first need to have a very clear imagination of what you are trying to build or what you're wanting to build, right? So in this particular case, I have taken a very simplified example, and it has been taken in reference from the internet itself. So in this particular case, this is an end effector, right? So whenever we have the whole robotics arm assembled, we need something as its end effector. This particular end effector is known as a gripper, right? So there are numerous end effectors that you can actually think of. You can have a drill, you can have a welding spot, you can have any sort of device as its end effector. But the most common one that we can come across is a gripper, as you can see over here. So this particular gripper can be designed in a few very simplified sets. So basically, talking about design procedure, whenever you are thinking of designing something like this, you need to have a complete thorough understanding of its parts, right? So this complete structure is not just a single structure that has been extruded, that has been gotten out of a 2D sketch. Rather, it is an assembly, right? So it has various small and very accurate parts that fit into each other very accurately, right? So we have two parts that are actually the gripper of the robot, the arm. Then we have two links that are joined to it so that they can affect the gripper. Then we have two gear systems, if you can see over here, right? So these gears can be actuated through a single servo motor. So whenever we will actuate the servo motor with some energy through a DC battery, so we can actually move the whole gripper into a particular position that can actually exert some sort of force, right? So this whole thing, this whole designing approach first starts with a 2D sketch, right? So this particular interface of the SolidWorks, for those who know, you must know that there are a lot of features that are available in this particular window, right? So we have a sketch option over here, if you can see. So whenever you want to start with some sort of design, you first have to sketch a 2D model, a 2D design for that. And then you will be using several features that are available. So let me just open a new window and let me, please let me know if it is visible or not. Whenever I want to open a new window, I'll just open a, I will click on Control N, and then I'll go for any of the parts that I want. So first I'll be designing the parts and not the on the part window. Is it visible, right?
Yes, it's visible.
Okay, cool. So here is a window for me, a blank window, a blank model where I can begin with. So here you can see we have the sketch model, then we have the features, we have surfaces, we have weldments, we have several features that can actually help us create a particular design in its all originality. Like we can assign the material over here, we can have simulations and analysis over here, and there are a lot more features. And as we know, we have a very short period of time. We might not be able to cover all of the features in this single video. So let us go through a very fundamental form of designing right now. So suppose I want to design a bolt, right? In the previous window, we just saw bolts, right? We have these bolts that are being implemented in order to connect the link. So let us think of designing a bolt right now. So first what I'll do is I'll select a plane, right? So here's a plane. Suppose I select the front plane. I double click on it, and then I want it normal to myself, normal to the screen that I'm actually currently working on, right? So whenever I want to sketch, there are a number of shapes that are already available in the SolidWorks that can help me actually create a base of 2D sketch that I want, right? So if you're designing a bolt, what does a bolt have? Just break it down part by part. First, it has a hemispherical end, right? We all have seen that. So for that hemisphere, we need something to design it off. So the best shape that I can have is a circle, right? Because the base of a hemisphere is a circle. So when I click at this circle element, I have several parameters under it as well. I can design the circle based on its perimeter, taking 3 points into consideration, or I can just drag it from the center based on its radius, right? So these are the two different kinds of circle that are available here. Then after I have drawn a very rough model of the circle, I can assign the value for its radius right over here, if you can see it, right? Suppose I need the radius of 1 centimeter, right? So here's the circle for 1 centimeter radius, right? Then I'll click on the tick option to save this particular profile. Now what I want to do is create a hemisphere out of it. So here is an interesting feature that you can actually explore. When you have designed, when you have made a very basic sketch out of which you are now going to shift into the feature, just exit the sketch after that, right? So now after exiting, we have a simple circle over here. Now then let's go to the features. And there are a number of features as you can see over here. We have extruded boss, we have revolved boss, we have swept boss, lofted boss. All these features are meant for different kind of designs or meant for different kind of features over the surface that we want to create, right? So for this particular case, what I can do is I can just revolve the circle around to create a sphere, or just revolve it half around to create a hemisphere. Am I right with that? So when I click here on revolve boss, it asks me to select a surface, right? So I'll select this particular feature. Now when I want to like create this revolution, I'll have to select the number of degrees up to what I want to try. So rather than going for 360, I'll go for 180 degrees, right? Just a minute. So like all these features that are available over here can actually help you like design very specific figures that you want to actually try, right? So just go through these features and you can actually design all the features that you want to design, right? Just let me select a plane first. Yeah. So when you get some rebuild errors like this, what you have to do is go back to your sketch. Okay. Make it perpendicular to your plane. Now every revolution needs an axis. That is something I forgot to tell, right? So now if I give a center line to this particular circle, right? In this particular center line, let us just save it. Then exit the sketch. And then when you have the complete figure with you, go to the features option, go for the revolve boss, select the axis around which you want to revolve, right? So now you can see if we have 360 degrees, the whole circle is being rotated. So we don't want that, right? We want a hemisphere. So just go through that. Just a minute, 180 degree, right? Just a minute. Be very careful with the units if you are going through it, right? Because sometimes units can cause a lot of error as well. So like this is one of the features that you can actually try, right? So in this particular feature, we have created a sphere. Now, in order to create a hemisphere, you just rotate it 180 degrees, right? After when you have created a sphere like this, right, you just have to add a few features. Like you can select a surface. After selecting a surface, you can create a cylinder out of it, right? So there are other features like the extrude boss and like revolve boss, which can help create a lot of like figures that you are actually looking over here. So what we tried to create was a link, that bolt that you're looking over here, right? Now, in order, other than this, there are a lot of other shapes that you will be requiring, right? For example, this particular shape over here. This one is the combination of a little circle and a rectangle, right? Here is another example, just for the sake of understanding. Every particular figure starts with a sketch, okay? So whenever you are going for a sketch, select a plane that you want to try. Then break down your particular 3D model into a particular 2D shape that you can try out, right? For example, I am taking here a rectangle of any random diameter or like length and breadth. So I'm not going into the dimensioning right now. Yeah. So after I have done that, in order to create the particular shape that we saw right now, add two circles. Like this is the very basic of designing that you can learn right now, okay? And this particular software has almost all the features that you will be requiring currently in order to devise that. Now, after you have made all the joints and you have created a single structure out of it, you do not need all the lines, like these intersecting lines, right? So here is an option of trimming entities. You can use it to trim. Like I don't need this. I won't be needing this. I won't be needing this part as well. I won't be needing this part as well. This and this, right? Okay. So be very careful whenever you are like creating such figures, because if your joints are not permanent, if your circle is not contacting the rectangle properly, so you will get errors like this and you won't be able to trim your entities, right? But after you have trimmed all of your entities and you have created a single figure out of it, what you can do is exit the sketch, go through the features, and then you have the extruded boss, right? Where you can actually just pull it out, the whole structure like this, as it shows over here, and you can create a figure of equal diameter or equal width that you want, right? So this is a very fundamental like session that we are conducting right now. So this particular thing will take a lot of like parts, small parts like this. You will need links, you will need the gear heads, you will need the bolts and all sorts of things like that, right? So like any doubts related to this? Like it's already 9 p.m. so I won't be consuming a lot of your time. Hello, am I audible?
Yes, yes, you are.
Yeah, so any doubts related to this till now?
Just checking the chat.
Okay.
There aren't any as of now. Guys, please put up your doubts if you have any in the chat, and we'll be here to clear them up. Okay, so Paritosh doesn't have a doubt, but he just mentioned it, that isn't hemisphere obtained by rotating quadrant by 360?
That can be done as well.
Okay.
Like it's completely up to you how to break down a particular figure into a 2D sketch, and then what all particular features that you are trying to use, right? You can use a semicircle also by rotating it 180 degrees. You can use a complete sphere also by rotating it 180 degrees. So it's completely up to you what shapes you are trying to use and how to use it.
Okay, Anshul is asking how we can clear our concepts of plane.
Concepts of?
Plane. P-L-A-N. He's just written that.
Okay, plane.
Yeah, plane.
There are no specific concepts to it. It's like plane is just the plane of visual orientation, right? So whenever you are studying also, you just want your whole pen paper, or like you want your paper or whatever you're writing on, right, perpendicular to the surface, right? So that you can write it easily. So same applies here also. Whenever you are trying to sketch something out in the design, you will just have something that is perpendicular to your surface or perpendicular to screen. It is just for the ease of visual orientation, and there is no specific concept after it.
Okay. Hiten says, any tips where to learn more?
Where to learn more?
Yes.
So like you can join the workshop right now. We will be teaching more about it. But other than that, the SolidWorks is also like a free source kind of thing. So there are a lot of internet stuff that you can find over here. You can find videos on that. You can find websites on that, like guiding websites that can help you understand the features more well. Like you can also have websites on resolving errors. Like we got some errors, right, in our design. So in order to resolve those also, you can refer to the internet. It is a good place.
Right. And I would like to add to that we have a playlist of SolidWorks on our channel as well by Sahil sir. So you can just refer to it. There are videos in the playlist and we'll be adding more to it. So that could be your source to learn as well. Yeah. Any other doubts, guys? Okay, Devansh says, do we really need to make every part by ourselves? Don't we have some pre-builds?
We do have some pre-builds, but that would be cheating, I guess. Anyways, like you can refer to pre-builds, but what is the charm after building the whole thing is that like you need every part to be very specific, because after designing a CAD, you're not just designing for particular visualization or just for simulation, right? After designing a CAD, you have further operations in manufacturing. You will either feed it to the CNC machine or the milling machine or the lathe machine, or you will be giving it to the 3D printing after slicing the whole model, right? So if your model has been built according to your requirements with your specifications, then whatever you will be 3D printing or whatever you will be building after that out of the CNC, it will be completely fitting into your job, right? If you'll be using pre-built things, that might not actually fit at all according to your dimensions, or there might be errors into it, right? So it's always better to build it yourself completely.
I hope that answered your question, Devansh. Okay, Anshul says, which software is better, Fusion 360 or SolidWorks?
Yeah, I was thinking this question might come. Yeah. So basically, we have a variety of software. We have Fusion 660, then we have the CATIA, we have the SolidWorks. My personal favorite is SolidWorks because it is very easy to use. This whole panel that you're looking over here, in a single window, you have all your features just listed out on yourself, right? So whenever you want to use something, you just go to that window. When you have all your parameters correct, you can just use that feature simply. And I have come across Fusion 360, and I don't find it very professional. Rather, SolidWorks is a bit more on the professional side. Like industries also approve, most of the industries approved this Dassault system, right? So that is why I would recommend SolidWorks.
Okay. So we have one more question lined up. Before that, I would just like to say that, guys, we have both our mentors here. So if you have doubts for any one of them, just let us know and, we will be happy to clear them. Okay, so it's a continuation question, Ayushman. Anshul says, can we do circuit designing in SolidWorks?
We can't actually. I don't think there is an option for circuit designing specifically. The Dassault system does.
Sorry to interrupt,
Yes.
but we can.
Circuit designing.
Yeah.
So that is completely new to me as well.
Yeah, we have a, I mean, not SolidWorks mechanical, but we have a SolidWorks electrical.
The Dassault system does produce like designing, right?
Yes.
Okay, everybody. So we have both our mentors on board. So kindly ask all the questions that you want to. Otherwise, I'll just, Orko sir, I'll just go back to the questions that we left after your session. Is that fine?
Yeah. Go ahead.
Just give me a second. Srujan is asking, sir, how these robots are applicable in MNC companies?
To me?
Yes.
It depends on the application. For example, in our company, we use Siemens NX. Now, Siemens NX, SolidWorks, CATIA, Creo, etc. All of these used parametric equations and parametric modeling. But again, every software has its pros and cons. The major reason why any of these softwares are used is, as Ayushman told you, it's for part modeling and part designing. So if you have to conceptualize something, you need to first think and build it, right? Just like a drawing. If you want to, just like the Wright brothers, if they wanted to make a aeroplane, right? They drew an aeroplane first. Similarly, if you have to make something, you have to model it. So to conceptualize, we use different softwares. That's the answer.
Okay. So this is a question for both of you, Ayushman and Orko. As a former mechatronics, what are basic skills one should a graduate should have before entering the industry? So what skills should a graduate have before the entering industry?
I'll tell my experience, and I think Ayushman can tell his. So to start with, the basic precursor is that you should be loving the concept of robotics and loving the topic of robotics. If you're not loving it, you won't be able to enjoy it, right? So that's the first thing out there. And after that, the basics must be clear. So if you are doing a bachelor's and coming into professional, right, the basics will be tested a lot, right? So for that, if I'm talking about mechanical, your mathematics should be strong. If I'm talking about computer science and the IT, your coding must be strong. Your data science, data structures, etc., must be strong. I'm not thorough with those domains, but I can tell something from my domain. So mathematics is a must. So matrices, then dynamics, etc., must be Cartesian spaces. You must be thorough with those coming from bachelor's, of course. But as you grow up the ladder, the complexity will increase. That's all I can say. Ayushman, if you want to give it a shot.
Yeah, Ayushman, if you like to add something to it. Or we can't see you on the camera. I guess there's some network issue.
Yeah, let me fix it. Hold on.
Yeah, so basically, like as we have already discussed, it is a very multidisciplinary stuff, right? If you are going into robotics, you have to learn a lot of things about it. So what we learned today was the basic in mathematics and the basic of a software that we can actually use to design, right? But other than this, we have the whole background of electronics. We have whole lot of control system stuff going around in that. And then we have a lot of things that you can learn. So it might take a lifetime to learn. But if you are graduating right now, like if you are on the verge of graduating and you want some skills of that, so the most finest of it will be designing. Like SolidWorks, you can design this this in the software. You should have the basics on electronics, like basic circuitry and understanding of microcontrollers and how to use them. Some understanding of building algorithms, right? So this much should do a lot for at least next 5 years. Like if you learn this much, then it will go a long way, and then you can actually grasp while you're on the way, right? So that's from my side.
Great. Okay. So I guess this would be the last question for the evening. This directed to both of you as well. So Anshul Raj is asking, good books for mechanics.
Good books for mechanics. I think S.S. Rao is an author who has, let's say, publications of mechanical publications. So, but again, I mean, it's something that S.S. Rao that's always followed. Ayushman, do you have something in your mind? But yes, S.S. Rao, he has a series of robotics mechanics, so you can follow that. S.S. Rao. And Ayushman, do you have anything in your mind that comes off at the top?
Not exactly. Like I don't have any book recommendations because I'm completely
Exactly.
based on.
So we all are the Gen Zs and the millennials, right? So we don't follow books as such. But rest assured, if you come into my webinar, you'll be having a much better understanding, a conceptualized understanding, because it's something that I acquired from my professors. I would love to share it with everyone out here.
Great. Okay. So thank you so much, both of you. It was great having you with us. And thanks to everybody who has stayed till the end. And guys, we have shared the feedback form. Kindly fill it. It helps us know you better, and it helps us, bring out the best that we can to you guys. And yeah, that's it from our side. See you tomorrow for the hackathon. Just a brief understanding of the hackathon, I would like to tell you that we will be giving you the problem statement, and there will be an orientation cum induction session where we'll be telling you on how to make the project that is there in the problem statement. And then you guys will be put up in groups, and then you will be given some hours to, finish the project, and then the evaluation will take place, and the results will be announced in your respective WhatsApp groups itself. So yeah, stay tuned, and thank you so much. Okay. So we have one more question. Would you like to answer, guys?
Go ahead.
Yeah. Devansh, recently companies are using LLM models, integrating them in robots, like a Google S Robo. Robo is able to detect and grab a dinosaur just by asking which of the following animal not present on Earth.
So are you talking about the large language model?
LLM, yes.
It's something, again, it's not in my domain, Tanya, and so I won't be able to answer that. It's into neural networks, and Ayushman might have an understanding of it. Ayushman, if you want to give it a shot, because I won't be having.
Actually, not exactly. I'm still learning a little bit into it, but I don't have the exact perfection in it.
Okay, no worries. Okay, guys, so stay tuned till tomorrow, and we'll be ending the session right here. So thank you so much. And yeah, good night. Have a great night ahead.
Thank you, everyone.
Thank you.
See you all.